So, assalamu alaikum. Good afternoon, everybody. A very quick question. Who is a data scientist here? Okay, not bad. Who is familiar with the data science topic? 2. Okay. So what I will do is that I will just try to skip some of the technical slide that I have. So I'm Baghdad Gherras. So I'm living in Dubai. I'm originally from Algeria, was born in France. I'm currently heading the data science and AI at Errata Capital, which is a fintech based in Dubai. I'm a consultant for Stanford Seed, which is an effort from Stanford to empower CEOs from India and Africa. And I'm an adjunct professor at Rochester Institute of Technology in the master's degree of data analytics. So till recently, I was a Google developer expert in product design. And before, I used to do for a couple of years data science and AI consulting in Dubai, helping government entities and large corporations building data science capabilities. So today, we're going to talk about machine learning product design. So my presentation was about, let's say, how we should build and enable AI product to flourish within the organization using, let's say, a platform-oriented strategy. But eventually, we can just focus on, for the sake of time, focus on the product design lifecycle, even though I will maybe spend a couple of seconds in a couple of slides. So just a snapshot. Why should we matter when it about data science and AI? So here you can see that 10. If you check the 10 biggest valuation company in the world, you can see that actually 7 out of them are based on data-driven business model. So currently, the most valuable way of driving a business toward the success is by being data-driven. And what happened is that more than a business model, it can actually be represented by powerful products. So the recommendation engine of Amazon. So, I mean, the figures are not 100% accurate because it's not coming from Amazon, but it's a McKinsey study that say that around 35% of the whole revenue coming from Amazon is directly through their recommendation engine, which basically one product generates billions of revenue. You have also the example of Netflix on their predictive customer retention algorithm that save 1 billion to the company. And recently, so in a different shape, you have a hardware device, which is Amazon Alexa, which is powered by AI, and that grew tremendously in the last years. Then, because of that, large company like tech company like Google, Microsoft, but a lot of different companies now are really going toward what we call an AI-first strategy, trying to build AI capabilities, developing business model around AI. So here is a graph that shows the traditional way of building a product. It starts with a kind of design thinking approach to identify what business problem are we trying to solve. And then we try to empathize with the user, understand their need, define this need, going into an iteration process, and then trying to experiment. And we start eventually a lean startup methodology when we're trying to build an MVP, test it, launch it, learn from it, and going into an iterative, let's say, loop, till moving into an agile engineering process when we're going to try to industrialize this MVP in a production grade product. And then you obviously get familiar with the agile methodology, like, okay, we're going to run on sprints, we're going to build our product backlog, and we're going to ship the product. When it comes to data science, for those who are familiar with data mining, so in 1980-something, one methodology was created, which was the CRISP-DM methodology, which is still somehow the methodology that is widely used around the data science community. And basically, it followed a little bit the same path. So business understanding, data understanding, so you are into the understanding phase. Then you start to experiment, to tweak with the data preparation, which is a big block of the life cycle, the modeling, okay? And then you're gonna evaluate and deploy. So somehow it's about understanding, prototyping, and deploy. But you get an issue on that is in most of the company, the model is never the problem. So I don't know about how you, what kind of expectation you have when you're gonna start your journey in AI, but one of the things I can tell you is that the answer is not necessarily being focused on the model. The model is a very, very a small piece of the problem. Actually, this is so a slide coming from Google in 2014 that show explicitly that this is what is actually your machine learning model, okay? So it's part of a bigger environment that will make your model successful. So I think that all of us have to understand that as a data scientist, we need to think as an ecosystem, not just in a narrow way of thinking to tweak, do fine-tuning on the algorithm for weeks, and then figure out that, oh, there is plenty of stuff that need to be solved before that. Because of that, data scientists spend around, let's say, 75% of their time not doing data science, and only 20% of the time doing what they should do. So this is a heavy slide. I'm not going to comment everything, but basically this is all the challenges that you have when you want to do machine learning and machine learning at scale. So basically what you have a team of data scientists that code in different language. Some of them will be Python-oriented. Those who come from statistical background will be eventually more keen to use R. Some other will use Scala and any kind of exotic programming language. And they use different frameworks. So some of them use TensorFlow, others use PyTorch, etc., and so on and so forth. So you have a lot of tools, a lot of programming language, a lot of way of running your models, and this creates a lot of heterogeneity. There is a question of the composability also. So what kind of architecture are you in? Are you in a monolith architecture, microservice architecture? The performance and success metric. So usually when we design a product, to ensure that we are designing for purpose, we try to identify what are the success metric. But in the machine learning life cycle, it appears that we have a lot of different metrics in different stage of the life cycle that require a lot of engineering to map these metrics, define them, and follow them. Iteration process. So Andrew Ng, so I will come back to him later, say that in his company, Lending.ai, they run daily sprint. It's not a 2-week sprint, it's a daily sprint in AI. Why? Because of the definition of machine learning, which is a combination between data, algorithm, and infrastructure. When you're gonna run your model, it's gonna give an output based on the data that you have. But data is not something that is static. It's dynamic. You're going to have more data, your data will change, the kind of data you are using is changed, and the output of your algorithm will change. So you need to consistently update your model and monitor the model. And this, we're going to come back later on. This is a very important point. The infrastructure, so, I mean, don't think that you're going to run your model like that and then it's going to scale easily. That's not the case. There is actually a lot of challenges to run machine learning at scale because most of the organizations in the world don't have the proper infrastructure to run AI. Then you have, of course, the scalability And I think that some of the speakers already talk about it, is the auditability and the governance of AI, talking about AI policy, ethics, etc. Doing machine learning is quite fastidious. In general, it will take you 13 steps to run a complete end-to-end machine learning lifecycle. So it's kind of long, and the thing is, it can spread across 6 different systems. So you have 13 steps across 6 different systems. It creates a lot of heterogeneity. And different teams are working on this different step with different skills, different techniques, different framework. So you lack of consistency. And the problem is, again, you have different environments. So once that you map your 13 step, then you're gonna start on your laptop. Then you're gonna start your training phase and deploying at scale on the cloud. And each of these 3 environments will require, again, to go back to some of the steps here and then work on it. So it's not just having a Jupyter notebook, getting a data set from Kaggle, running an algorithm, and it's done. I have actually a successful result. So I like also to talk a lot about open source technologies. So AI advancement is really driven by the open source community a lot. So even on the best practice, the methodologies, and the best technologies come from the open source world. Cubeflow is an effort from Google that has been released this framework to run machine learning algorithm in an end-to-end way to basically do your 13 step in one platform. And Cubeflow is very interesting because it has been designed, so this is like the different tools that you will find in this platform. One of the points is that Cubeflow run on top of Kubernetes. So anybody is familiar with Kubernetes? Okay, so Kubernetes is basically, has been released also from Google in 2014. 2014, because this is what they use internally to manage their container, okay? So they have an orchestrator to manage a container. And you remember you had, sorry. Yeah, so you had this, all those steps, okay? It's kind of different layer, you know, runtime, operating system, etc. And Kubernetes by half will support in a horizontal way those 5 layers. So it's abstract half of the job that you have to do to maintain your environment. So because you have Kubernetes that is running as an underlying layer, what will happen is that, sorry, this is just like a typical Kubernetes description, but I'm gonna skip it. So you're gonna run Cubeflow on top of it to basically, to cut all the different differentiation that you have on in the environment. So to make it easy, you have one Kubernetes layer, one Cubeflow layer, and then you can run. Now you can start working on an end-to-end machine learning lifecycle in an easy way and consistent way. Okay, so this is like just like a couple of examples of end-to-end machine learning. And just to tell you that it's very, very recent that we adopt this, strategy is Google just commercialized his AI platform on the next 2019 in April, so a couple of months ago. So a couple of months ago, organizations have an end-to-end AI platform to really run machine learning at scale. Before it was not the case. For the question, we'll go later. So my introduction was that you need to be platform-centric to be product-oriented. You need to start by getting the right infrastructure, building the right platform to then flourish your innovation process to build successful products. This is for, a typical organization that eventually, I'm just saying eventually, if you have a technical team that is dedicated to maintain the core AI infrastructure, you have eventually a center of excellence. This is where the data scientists will do experimentation, and then they will join force to build product in the middle. Okay, so there is a very interesting article from HBR, from Emily Glassberg-Sens, who is the head of data science at Coursera. And some of the outputs are spread in this presentation, but also others from our dear friend Andrew Ng. So why I'm trying to give you this example is because Andrew Ng is not an entrepreneur like any others. He is definitely an AI researcher, so he has a very strong academic background. He's at the cutting edge of AI. He's been doing AI, corporate AI in Google Brain, in Baidu. He's a successful entrepreneur in Coursera and Lending.ai, which is like his latest company. So he's an entrepreneur, he's an AI researcher, and he's a successful, let's say, AI practitioner because he built AI product that has been successful. One of the things that he's saying is that when you want to build an AI product, it's really kind of like a virtual life cycle. So you have a product, this product attracts user, this user, by using this product, will create data, and the more you get data, the more your algorithm will become. So product lifecycle with machine learning lifecycle are really tied together. Sorry, I have another one. One of the interesting things also is that in company, usually you are not going to run one algorithm. You're going to run different algorithm for different application. But because you have a kind of platform-oriented strategy, what's going to happen is that the data augmentation that will come from one algorithm will feed back the underlying layer in your, let's say, data lake, and then enrich the whole ecosystem of algorithm that you will have. So the more algorithm you have, the more data you get, and then this feed your data lake to enhance the output of the other algorithm. One of the problems that we have also is because machine learning is a dynamic process, you cannot just say it's a go or no go for deciding if you should productionize an AI product. The thing is, you need to follow the metric, because if the metric keep getting enhanced because of the slide before, then eventually you should run your AI product, let's say, in a canary way. So you let it run in behind without allowing, let's say, user to use it, but it keep getting better until at this time you can you can, let's say, think about commercializing. Maybe I'm gonna just, sorry. And with this, so this is a typical machine learning life cycle that comes from Uber Engineering and who sum up the whole process of doing a machine learning product. So it started with, let's say, understand the business need, and for that, I advise to use something called the design sprint that also comes from Google to really come up after 3 days of sprint with an accurate business need, some sketching, prototyping, user research, to really say, okay, if we spend time on something, it should worth the time that you are spending on. You should also use for your MVP definition, the value proposition canvas. I think I have it somewhere. I don't know if I will have the time to show you. And then you start using the same lean startup methodology that we had, but applied for data science, which means that you will build a minimum viable model, not a minimum viable product, okay? To start your data science, let's say, prototyping step, evaluating, training, iterate till you start the production phase. Production, deploy, and make prediction. But then, as I said, as it's a dynamic process, you need to monitor this prediction and make sure that you are not getting jeopardized by data that were not in your ecosystem before and will alter the quality of your algorithm. And finally, what is very important is the UI UX of your AI product. So what I'm saying is that some of the AI products are not that straightforward, like an Amazon Alexa. You just press the button and it works. In a lot of organization, it's either a mobile application or a dashboard, and you need to expose the, let's say, AI product in a very friendly way to enhance the usability and adoption within your user, either external user or internal user.